Okay, so here for the part B, 2 times u, what is the theory we have already applied here? That is for the scalar multiplication. Scalar multiplication. And the third one, there we have u minus 2 over 3v.
For the multiplication, just multiply all numbers. In adding, you add all numbers.
So for the second one,
Yeah.
second one, you just need to multiply the entire u vector by 2. 2 times 0, that is 0. 2 times 2, that is 4. 2 times 4, that is 8. Then the final answer would be 0, 4, 8.
Oh, okay.
That's it.
How do you do last one?
Last one, u minus 2 over 3v. So you have the vector u, okay? So then you need to, we have the vector v as well, but we need to calculate 2 over 3 vector. So first calculate this one. To calculate this one, what you have to do? You need to multiply this vector by this 2 over 3 scalar. Okay, is it clear? Okay, let me show you. So if we have u minus 2 over 3v, so we have this u directly, but for the 2 over 3 vector, vector v is 1, 3, 5. 2 over 3 means 2 over 3 vector v means 2 over 3 times 135 vector. There we have 2 over 3, 2 and 10 over 3. Okay. Then u minus 2 over 3v, that is, u means 0 to 4, right? 0 to 4 vector minus 2 over 3 to 10 over 3. Okay. Then you need to do the subtraction. 0 minus 2 over 3. That is
Minus 2.
minus 2 over 3. Yeah. 2 minus 2, that is 0. 4 minus 10 over 3 means 2 minus 3, 2 over 3. Those are the values. Okay. It's clear, right? How to do these ones?
Yes.
Okay, now you can do example 5, example 6, example 7 as homework. Then we'll move to the products. Okay, so here we are going to talk about the scalar product. Scalar product, we are giving kind of another name, that is dot product. Scalar product is equals to dot product. The same thing, two different names are referring to the same thing. So the definition, let u, vector u, if we define this vector u with n number of spaces, here we have the vector v also in n number of spaces. So those two be vectors in r to the power of n. As I told you earlier, we have these ones in r to the power of n spaces. Then the scalar or the dot product. Scalar product, another name for the scalar product, we say it as dot product of the u and v. We normally denote it as u dot v. So that is for the dot product, u dot v. And it's defined by, how we gonna define by u1 v1 plus u2 v2 plus u3 v3. Likewise, the what we call the respective components, we are multiplying those ones and add all these values together. So here u1 v1 plus u2 v2 plus u3 v3. Likewise, the final value is equals to the total. So here sigma means the total. We are adding all these values, right? Sigma, when I is equals to 1 to n, because we are starting with 1 and we have n spaces, n number of planes, then ui, vi. Is it clear how we define this dot product?
What is
U
U
dot.
and V?
Yeah, so for example, if I show you, so see, the example 1, I'll do it and show you. So here, it's like this. The vector u, okay, the vector u, how to erase this one? Okay, let me get a new one. So the vector u is 3 minus 2, 1. This one is a 3D vector. And vector v, we have 1, minus 5, 6. Okay. to calculate u dot v. Okay, to calculate u dot v, that is, we need to consider the dot product of these two vectors. Okay, then this means we have the answer as 3 times 1. Okay, minus 2 into minus 5. And then 1 into 6. So here we have the dot product. Okay, sorry, the addition of these ones. No, sorry. So we need to take the dot product of these two, which means 3 into 1 plus minus 2 into minus 5 plus 1 into 6. So now for all these ones, then the dot product will be 3 plus 10 plus 6, that is 19. Okay, so you just multiply the first ones together. And then here we have the second components together. And then we have the third components together. Here we have 3D vectors now. Then 3D vectors means this one is X, this one is Y, this one is Z. Again, this one is X component, this one is Y component, this one is Z component. So we just multiply X into X, Y into Y, and Z into Z. Likewise. Is it clear?
Yeah. Yes.
Are you sure? Okay. So can you complete this example one? Don't look at the answers. Try to find out A, B, C, D, and E. Those ones. And then we'll move with the angle. A, B, C.
Yeah. Do you know the previous example, like u minus 2 over 3b?
Sorry? Sorry, I didn't hear you properly.
Yeah, but
I didn't hear you properly. So the part B, now we already did the part A now. Then we have part B. Part B is U dot V. Now, earlier we had U dot V. Now we have V dot U. Okay, were you able to figure out, find out?
Yes, I did B.
Okay.
What is U1, U2, U3?
C or B?
Abba, what is U1, U2, U3?
Okay. U minus V dot W, right? The last one.
Yeah.
Okay, so there what you have to do for the part E. First, you need to calculate U minus V vector. So how we gonna find out U minus V vector? That is 3 minus 2, 1 minus 1 minus 5, 6. Then U minus V vector, it will be 2, 3 minus 5. Now we have U minus V vector now. Then we need to take the dot product of U minus V vector with vector W. Okay. Then 2, 3 minus 5. The answer what we received there into the dot product of W, that is 1, 2, 3, 4.
1, 2, 4, 3.
1, 2, 4, 3. Now what will happen? So now what will happen? So the issue is here, you can see these two vectors are 3D vectors. We have X, Y, and Z. Okay, then this one is a 4D vector. There we have 4 dimensions here. Can we take the dot product?
No.
No. Actually, we can't take the dot product. That's why it says as not defined. For the second one, C, part C also, it's like this. Here U dot V, U is in 3D plane. Okay, this one is U. The vector U is in 3D vector. W, it's a 4D vector. See, these two we can't take the dot product. Because of that, C also it's not defined. Okay? Okay, now we'll move to the next theory. So then we have theorem, let vector u and vector v and vector w be vectors and k is in real numbers. We have few initiatives according to these vectors. So what are those initiatives? The first one is vector u dot v. The dot product of u dot v is equals to the dot product of v and u. See, u dot v is equals to v dot u. Is it clear? That is the
Yes.
first initiative. Okay. Then the second initiative is, okay, I'll erase these ones. Then the second initiative is what is it? u times u dot, here we have v plus w vectors. So how we solve this one? First, we need to anyway take the v plus w vector and then need to have the dot product with u and v plus w vector. Is it clear? This one we can rewrite it as vector u dot v vector plus u dot w vector. U dot v vector plus u dot w vector. That is the second theorem. Okay, second initiative. Okay, is it clear? The first one and the second one. Then we have the third theorem. The third theorem belongs to the scalar multiplication. So we have the u vector and we are multiplying this u vector with a k scalar. And then we take the dot product of ku vector and vector v. So this one is equals to, first we can take the dot product of this u and v vector and then we can multiply that value by k. And also again, this will equals to u dot kv vector. So earlier we just multiply this u vector u from this k scalar and then take the dot product of ku vector and the v vector. The final value of that is equals to the final values of these two expressions as well. So what are those expressions? K times u dot v and also u dot kv vector. Is it clear? Uh, okay. So those are the first three initiatives we have. And the fourth one, okay, and the fourth one, there we have u dot u. So what do you think u dot u? What do you think u dot u? What would be the value? So u dot u vector is always the final value. Dot product of this one is always might be equals to 0 or else it has a value, a positive value. So u dot u vector is greater than or equal to 0 and u dot u vector is equals to 0 if and only if the vector u is equals to 0. Those are the only four initiatives we have according to the dot products of these vectors. Okay, so the definition. Is it clear up to this point? Are you sure? Is it okay? Can manage? What do you think?
What does the UVW
UV?
mean?
UV means?
Yeah.
U means vector U. So here, for example, it can be either any vector. So how we define the vector? Vector means vector u. This one is vector u. So for example, okay. So as the initial stage, see how we define this vector u. Vector u, we can define it as u1, u2. For example, vector u will be 2i plus 3j. So we have two-dimensional vector here. So vector v also same as that. We can define this vector v as how? v1 comma v2, v1 comma v2. How? It might be 5i plus 4j. That's how we normally define all these vectors. So u can be, vector u can be 2, 5, 4. If it's a 3D vector, vector v can be 1, 6, 0. So these are vectors. How we denote these vectors are like this. U, V, W. Is it clear?
Yeah.
Okay. So here now, okay. So here now, there we are going to learn a definition. If two vectors, now again, so here for the entire chapter, we are going to talk about these vectors. So again, they have asked us to consider that vector u and v. Okay, we have vector u and we have vector v. Now what has happened here? Okay, let me write it here. Okay, now you can see. Okay, now here they have on this definition, they are talking, we have two vectors, vector u and vector v. Now what has happened? Vector u and vector v are said to be orthogonal or perpendicular. Perpendicular in the sense, these two are looks like this. So then that means these two are intersect with 90 degrees, right? So if these two are orthogonal or perpendicular, then we can conclude that the dot product of these two vectors is equals to 0. Okay.
Yeah.
That is only if these two u and v vectors are perpendicular or orthogonal. Now look at this example. Check whether it's clear for you. Example 2. Show that the vectors, okay, now on example 2. Show that the vectors u. Vector u, there we have 7, -2, 4. And vector v, we have 2, 5, -1. Show that these two vectors are orthogonal. If these two vectors are orthogonal, what the rule we have? The dot product of these two, should equals to 0, right? That's what we learned. Then we are considering the left-hand side so that we are taking the dot product of u and v. Dot product of u and v. How we gonna calculate this dot product? So 7 times 2, that is 14. -2 times 5, that is -10. 4 times -1, that is -4. What is the value we have? The value is 0. That means this dot product is equals to 0, which means these two vectors are orthogonal or else perpendicular to each other. Can you do that one by yourself? The example to this one. Do it by yourself. It's heavily raining here. You can hear me well, neither. Are you
Yeah.
sure? Is it lagging?
Yes.
Tell me. Okay.
Okay. Yeah, I got.
Okay. You got my point, right? So those two
Yeah.
are, then the final dot product is equals to 0. Then that means actually these two vectors are perpendicular or else orthogonal. Okay.
Yes.
That's how we normally show. Okay. Do the example 3 as well. Now it's a little bit of different question. Example 3. how to do the third example? Okay. Is it taking such long time?
No.
Okay. So, what did you do for the example 3? What they asked
Hey,
us?
I got like 22/5.
No, the m should be minus, m should be 1, the value of n. So what they're telling, find the values of n. So
Wait,
find the
but
values of n. The
but
vector
why is
u,
it
uh,
says 12 there, but in the answer it says -12?
oh, I see. Here it should be, I think, a minus 12. Okay, that's fine. So if you do like that, then if you go through with this example, then it would be 12 plus 5m plus 12 minus 2, right? So 1 times 12, that is 12, minus m times minus 5, that is 5m. 4 times 3, that is 12. Again, 2 times minus 1, minus 2. Then 12 plus 12, 24. 24 minus 24 minus 2, that is 22. 22 plus 5m. Since these two vectors are orthogonal, that means the dot product should equals to 0, which means m is equals to minus 22 over 5. Is that the answer what you received?
Yeah.
Okay, okay, then you are correct. Okay, now you can do the example 4 as homework. We'll move to the next part of the theory. So the magnitude of a vector, that one is really easy. So for the magnitude of the vector, magnitude means so the magnitude or the length or norm. For a magnitude of a vector, we are using three specific names. One is either magnitude, or else we can say the length of the vector, or else we can say the norm of a vector. So if we consider vector u as u1, u2, u up to un, if we have r to the power of n space, okay, then how we define the magnitude of the vector u, that is modulus u, or else we can say it in computationally, we draw these two lines, that is squared of, okay, sum of the squared of these values u1 u2 likewise squared u1 squared plus u2 squared plus u3 squared likewise until un squared. Okay, we just add all these values and then we are taking the square root of the total summation.
So what is
That
UN?
uh,
The UN.
yes, up until u to the so the final value. So for example, if I explain you an example, let's assume you have the vector u as 3 minus 5 and 2. Then the magnitude of the vector u, or else norm of the vector, or else length of the vector is square root of 3 squared plus minus 5 squared plus 2 squared. So 3 squared, that is 9, plus minus 5 squared, that is 25, 2 squared, that is 4. We just add all these three values together and take the square root. That is 4 plus 9, that is, we have 13. 13 plus 25. There we have 13 plus 25, that is 13, 48 or something. 38, right? 9 plus 4, that is 13. 13 plus 25. Okay, that is 38. Then the magnitude is square root of 38. Is it clear?
Yeah. What does the two line mean?
Two lines,
Side.
that's the computationally how we define this one. Modulus. Modulus means actually we denote it as single line. Modulus. Modulus means the magnitude, no? We take only the positive value, no? So in vectors, in computational vectors, how we define that is from this. This is the notation. Okay?
So
Uh, so if you are writing, then you can use this only single value, modulus. This one define the magnitude. Okay? Is it clear?
yes.
Okay, if I show you that one in an example, magnitude of a vector, how to define a magnitude of a vector, how to define a magnitude of a vector. then it would be see, they have used with two lines, or else you can say they have used it with a single line as well. Modulus A, mod A. See, modulus A define x square plus a square, the length. We take only the positive value. Okay, is it clear?
Yes.
Okay, that's how it works. And then, okay, now do the example 2. Do the example 2. Okay, can manage.
Yeah.
Okay, then the example 2 also completed. Okay, that's fine. So we can do another 1 hour session tomorrow and then we can complete the rest of the theories in vectors. That's fine. Altogether, we did like almost 3 hours now. That's fine. So what you can, I just have to send you, right? This one. Okay, I'll send it right now. And the recordings also, I'll send the previous 2 links now. Now, in the sense, I'll upload those 2 videos to the YouTube channel and then I'll send the recording. I'll send the link because already converted it, but need to upload to the YouTube. Okay. Then that's all for today. Then see you tomorrow at the same time, around 8 p.m. from Sri Lankan time. Okay? Thank you. Thank you. Okay. Do the homework. Bye. See you. Okay.